Good morning, dear student. As we are doing the chapter work in energy, so today we will discuss about the energy. So first of all, what do you mean by the energy? Energy is what? Energy is the capacity of doing work. That means for doing a work we need energy. Okay. Now there are so many forms of energy like kinetic energy, potential energy, chemical energy, heat energy, solar energy, electrical energy, and so on. And in this chapter we will discuss some amount of energy in detail. So firstly we will discuss about the potential energy. For this, let's just take an example. So dear student, this is a hammer. If I raise this hammer to this height, at this time this hammer has a potential energy stored in that. Whenever an object is raised to some height, some amount of energy is stored in it, and that energy is potential energy. Now the potential energy of this hammer is used to do some work. Like if we take this hammer and stuck to a nail, the potential energy stored in the hammer is used to fix a nail at a point. That means at that time the energy stored in this hammer is used to do some work. So the energy possessed by the virtue of an object due to its height, and when the object is at rest, then it has possessed a potential energy, and that potential energy is used for doing a work. Okay, now let us take another type of energy, that is kinetic energy. The kinetic energy is the energy which is possessed by an object due to virtue of its motion. That means whenever any object is in motion, it is due to the kinetic energy. Let us take an example, like in our rooms our fan is rotating. When the fan is moving, then it has a kinetic energy in that, and when the fan is not moving, then it has a potential energy. Another example, this is a ball. When I take this ball at this height, then at this time it has a potential energy. Now I leave this ball. Now when the ball falls down, it has the energy, that is a kinetic energy, and when it comes up again at this height, again it got a potential energy. That means, now which type of energy is there in this ball? This ball has two type of energy, potential energy as well as kinetic energy, and the sum of the potential and kinetic energy is known as the mechanical energy. Let us take another example also. For example, if a bird is flying in the sky, so which type of energy it has? When the bird is flying, that means bird is moving, that means it has a kinetic energy. But when the bird is flying, it is at a certain height. It is flying in the sky, so it is at some height. That means it also has a potential energy. So the sum of the potential and kinetic energy is known as the mechanical energy. Okay, when any object has both type of energy, kinetic as well as potential energy, then that energy is known as the mechanical energy. Okay. Next type of energy is heat energy. Now, whenever any object is hot, that means it contains heat. So when an object contains heat, that means it has a heat energy, and the heat energy is measured in the calories. Okay, so when an object is hot, the water is hot, and we use that heat energy, that is you measured in the calories. Now the next type of energy is chemical energy. Actually chemical energy is from where do you get the chemical energy? The chemical energy is also present in the fuel as well as in the food. Now what are the fuels? Fuels are used to produce some work, like coal. Coal is a fuel, petrol is a fuel, diesel is a fuel. These all fuels are used in our daily life to do some work. Like petrol is used in our cars, and then that coal is used or petrol is used in our car to run our vehicles. Okay, and this energy is also present. This is a form of a chemical energy. Now in the food, the energy is also a chemical energy. Okay, and that energy is measured by also, food energy is also measured by the calories, but there is a difference in the both unit. The heat, I have said you earlier that heat is also measured in a calories, and the food is also measured in the calories, but the both calories are different. In the heat, the calories start with the small c, and in the food items the calories start with the capital C. In the food items we also measure the calories by the kilocalories also. If you take any juice bottle or any juices ingredient, if you check at the top in the ingredient there is written K calorie. K calorie is kilocalorie. That means we are using that energy, and these are a type of a chemical energy, and that energy when we take it, it gives us energy to do some work. So these are some forms of your energies. So next type of energy is light energy. As we will know that the main source of light in our environment is sun, and the artificial source of light that we use in our homes are bulb, tube light, etc. Have you ever imagined that what happens when light is not there? Are you able to see anything? No. So as we see that if light is not there, we are not able to see anything. So the light is also an important source of. So we have studied that kinetic energy is energy that is possessed by the object when it is at the motion, and the kinetic energy is denoted by K dot E, that is kinetic energy. Now the formula for the kinetic energy is half mv square. Now we have to derive it from where this formula is made. So let us do the derivation for the kinetic energy. So let's do the derivation for kinetic energy. For the derivation of kinetic energy, let us consider this is an object having a mass m. When a force is applied to an object, it moves with the velocity, and that is their initial velocity. After some time, the object reaches at some distance having the mass m, and force is applying, and after some time its velocity is final velocity. This is a distance which an object has travelled. No. So we have studied earlier different equation for the law of motion. So according to law of motion, according to the equation of motion, let's take an equation of motion, that is v square minus u square is equal to 2as. Now from this equation we will calculate the value for s. So the formula becomes u square minus v square minus u square upon 2a. Now as we know that the force is equal to m into a, that is force is equal to mass into acceleration. Let's take this is equation 1 and this is equation 2. So now as we know that in this case some work is done. Okay, when this object is moving from this position to this position, that means some work is done. Now in this case we have to find out how much work is done. So work done by the force in displacing the body, that is work done is equal to force into displacement. Now we will put the value of force and displacement from the equation 1 and the equation 2. So we will write, put the value of F and S from equation first and second. So let's put the value of F is m into a, and the value of S is v square minus u square upon 2as. The a is cancelled out by the a. So now we will get 1 upon 2 m v square minus. If initial velocity is 0, when it is 0, when the object starts from the rest position. So if the initial velocity is 0, then the work done is equal to, as we know that work done is equal to half mu square and v square. Let's take multiply it, m v square minus half into m u square. Now if the value of u is 0, that means this whole equation becomes 0. So the work done is equal to half mv square. Now in this case, the work is done for moving an object. So this work done is converted into kinetic energy. So kinetic energy, the formula, we have derived the formula that kinetic energy is equal to half into m into v square, where your m is mass of a body and v is the velocity of the body.